Hi and welcome to my YouTube channel. Merry Christmas to all my subscribers and anybody viewing. Just a quick update on the channel really. Getting busy. I've had quite a few repairs in. I'm down to my last two repairs at the moment. One I'm sort of 2/3 of the way through, and that's an MFJ 20-meter transceiver, which is quite interesting. It's come in for repair. Unfortunately somebody's got at it, so it's a bit mangled inside, but fingers crossed I'm nearly there with it. Really the only other thing I got in after that is a Roberts R861, I think, which is a PLL world band receiver. Basically I think it goes from about 0 to 1 gig, so off the top of my head, but I will show that later on. But main reason for today is to show you what I've got that my brother bought me for my birthday, so thanks Trev, and I'll put a link to his channel underneath as well, because he has got a YouTube channel. He's mad on headphones. Oh, and his partner Joe as well. This is from both of them. Arrived for my birthday in November, so just a second and I'll show you what it is. Here we are then. It's a little bit of Christmas fun. There's been a lot of talk about this on the Vintage Radio forum, so everybody's excited to see this. So it's a Haynes. You make the motoring magazines. Build your own FM radio advent calendar. Quite a comprehensive instruction book. Now, obviously it is now the 9th of December, and I've already opened it. Didn't think of doing a video, but well, I did think of doing a video, just one of them things, never got round to it. So what I've done, I put them all back in. So what I'm going to do then is I'll go through each individual day up to today, which is the 9th. Didn't open yesterday's either, that's naughty. Slap wrist. So what we'll do first of all then is we'll open door number 1. It says suitable for young and older, so you know, that includes me, I think. I'm somewhere in between. So first off then, looks like we've got a loudspeaker. So what you've got to do basically each day is pop the book open and have a look, see what it says. So basically what it's telling me to do is to, it tells you a little bit about the speaker. So there's a flexible diagram, and you can move it in and out, which you can. And if you tap it, you can hear it. So that's basically the principle of the thing. So what it's asking you to do is to hold the wires onto a AA battery. So one of the wires remaining in contact with the battery, and the other one just briefly touch it. So let's do that a minute. If I can hold it that way, it should make a pop. Hopefully you can hear that. So only connect it briefly because I don't know whether it will damage the battery or flatten it. So what it's saying is every time the contact is opened or closed, there'll be a cracking sound, which you heard. And basically a strong magnet is located on the rear side of the speaker, which is here. You should be able to tell that's a magnet, which it is. So it's got a wire cord attached to the speaker diaphragm connected in the interior. So there's a little wire connected inside here to the speaker coil, which is in the center. And the current that flows through the speaker makes the wire and the coil move, which generates a sound impulse. I'm reading this, by the way, I'm not this fantastically knowledgeable. So it says basically test it in both directions. In one direction the speaker is pulled, and the other direction the speaker is pushed. So I mean, we can't see that on this speaker, it's just too small, but basically it works both ways. But just in one direction the speaker's pushing out, the other direction it's pulling in. But the same sound is produced in both instances. So that's day 1 done. So day 2 then. Let's get day 2 open. Where's number 2? Number 2. Here we go. So day 2. We have a battery holder. So it's for 2 AA batteries, so let's pop them in. I've got a couple here lined up. Avoid short circuit them, obviously, you don't want to touch the ends together. Where are we? Blah blah blah. So repeat the experiment from day 1. This time we can hold the wires together. And it says basically it should be significantly louder, which it is. And we can reverse them as well. No difference. Just the speaker's moving inwards rather than outwards. There we go. Day 2 done. Number 3, here we go. Hello. We've got a resistor. We have got a resistor, so I can guess what this is doing, but let's have a look. So basically it's headed reduced current. Ooh. So it's a 1K resistor, 1 kilo ohm. That's denoted by the bands, so it's, by the looks of it, it's brown, black, red, and gold is the tolerance. That's just told me that. So brown is 1, black is 0, red is 00, so that's 1000 ohms, which is 1K, and the gold ring indicates 5% tolerance. So it says they're often used to reduce the current flowing in a circuit. So in this case, a resistor is connected in series from the loudspeaker to the battery. So pretty much all we're doing is connecting one of these leads to the resistor. Again, we're just holding these on at the moment. To there. It's going to be easier to clip that on actually. So let's just clip that on. We can. Go on, clip. Probably not the best clipping tool. Yeah, that should do it. So the idea on this is basically it's going to restrict the flow of current in the circuit, and then it should be a lot quieter. So let's try it again. Well, you can barely hear that, it just sounds like scratching. So 1 kilo ohm is restricting the flow of current through it, and again it's saying that the direction of the current through the loudspeaker has no effect on the sound. And beware that experiments with the integrated circuits, the polarity has to be correct. So although we can mess about now, we can reverse the polarity on it. No effect at all. If you're using integrated circuits and you reverse the polarity, you'll blow the IC, as we've seen in some of the radios I've repaired. So that's day 3. So let's go with day 4. Oh, now we're talking. Now we're talking. The breadboard. So there's quite a lot of gumph about the breadboard in here. So it's used to carry out all these experiments. It's a perforated block of plastic that's got 270 spring clip connectors inside it. Again, you can use this over and over. They are really useful for just knocking up circuits to see if something's working. So say it is it's difficult sometimes to get the wires into these. You can stick a pin in there first if you want to open them up if they're a bit stiff. So you can just pop, this is just a capacitor lag. You can see it's held quite firm there. You can see that, but I'm probably a bit in the way, aren't I? But yeah, that's a pretty strong hold, that. So what it's asking us to do is to build the little circuit now, so we can get rid of my little clip, so we can actually make a circuit. So looking at the diagram here, we're going to have the speaker in A and Y. So all you're doing is just pushing it in. The terminals are numbered, letters even. So you've got numbers along the top and letters down the side. So we're going in A and Y there. And our 1K resistor is going in circuit. So these are linked vertically. So by putting that in there, I'm connecting to this negative. And that's going up to this pin here. Just 10, 11, 12. So that's the speaker circuit in. Next we've got the battery connector. Again, this does need a bit of straightening out. So we've got an X and a Y, which is the positive and the negative. So it's like in a radio, you've got your power rails. So the top one is the positive, so we're going to pop the red wire in there. And down the bottom is the negative. Now when this goes in, you should hear the speaker. So I'll shut up a minute. Yeah, you can just hear it. So again, we don't want to leave that in for any prolonged period of time because it will drain the battery. So let's get on to day 5 down here. And we have a bit of wire. So basically they're using this as a switch contact by the looks of it. So there's a lot of wire for a switch contact there. So I'm assuming that we're using this for quite a bit of it. So remove the insulation on the ends to a length of about 8mm. Let's use these cutters. Unusual, but there you go. Switch would have been nice, but this is back to basics. So we need to remove some wire. So we stick that one in there. And that went in. Oh, not they've moved the resistor. That's crafty, isn't it? Same rail, but down to position E now. So you've got to completely remove the insulation by the looks of it. So let's completely remove that, both sides. So basically just bridging from there to, I believe, there. Connecting that back up. So you can basically see this is a break in the circuit now. So let's get you in a little bit closer. Hopefully you can see that. Oh, there's my speaker out. Yeah, I think if you've got one of these kits, you might pay you to just strip back a little bit more of the insulation. And they're also talking about clamping the power wires down to the board, just with a little bit of wire to brace it. So we'll do that as well. All good fun, isn't it? But say, it's a learning thing as well. It's going to teach you a bit about radio, how radio works, or how circuits work to start with by the looks of it. It's going to be interesting getting into the insides of it later on. This is fiddly. Yeah. I don't think that's a good idea, that clamping with the wire bit. There we go. So it's just holding that wire, stop the terminals getting pulled out. So now we have our switch, so we can touch that onto there. I mean, you can't hear it because there's no amplification, but I can just about hear a little click every time I touch that. So day 6. Let's find number 6, which is up here. And we have an LED. Get on. Okay. Now the circuit's starting to get complex. They're moving stuff around yet again. So, LED is going to be used later as an indicator light for the radio. So it's basically going to tell you whether the battery's on or off, and it still has voltage. It's always got to be operated with a 1K resistor in series and should never be connected directly to the battery. If you connect that directly to the battery, it'll just pop it, gone. So it needs a bit of resistance to restrict the current through it. So there's 2 wires on this. I don't think you'll be able to see inside, but let's get you in a bit closer again now. So you can just about see inside. There's a large sort of triangular shaped pin there, which is the negative, the shorter of the 2, and that's the cathode. That must be connected to the negative side of the battery, and the longer one to the positive side. So if you reverse it again, it's either not going to work or you'll pop it. So let's rejig this as per the book here. So our resistor's moving again. It's now going in terminal 14, second one down, up to the top. Our switch is coming out of there. Our switch is going in here underneath the resistor, jumping across 3 down to there. Hopefully it'll go in. There we are. So that's one of our switch contacts. Speaker's moving here. Hoping we'll get some amplification at some stage, so we better hear this, but so that one's being tricky to open. He's in. He's in. Right, this one down on the negative rail. Again, remember the polarity is not important on the speaker at this stage. So, switch contact. It's going in line with the speaker. And it looks like we've got the LED going in. Let's make sure we've got this the right way around. So positive and negative going in there, and we need a little bridge of wire to pull that into the negative side of the circuit. So let's just cut a little bit of wire for that. So just linking from, oh, there we are. Ha, there we go. Right, yeah, so at the moment we've got a complete path through. I mean, you can see what's happening there. So looking at the diagram here, this is quite a nice little circuit diagram so you can see what's happening. So current's flowing down through this resistor, so we've got the positive coming through this resistor, and that's open circuit at the moment, look. So there's nothing going to the speaker yet, but there is current flowing in the circuit. It's coming down through that resistor, through the LED, and then back to the negative. So you can see it's got a complete path around the circuit there. And by putting that switch on, you're switching the speaker in. So it says no current will flow if the LED is connected the wrong way round. It won't damage it, but it will remain switched off. Speakers connected in parallel to the LEDs so that a small additional experiment can be carried out. You'll hear another quiet cracking sound when you close the switch. The LED will switch off. So it says the speaker's small resistance causes the entire current to flow through the speaker, meaning the LED does not contain enough sufficient current to illuminate. So that's still in circuit, it's not getting enough current to illuminate. So everything's flowing through the speaker. Nice, there we go. So, I think day 7. Yeah, I've opened day 7, but I think this is where I'm up to now. So this says stored energy. Let's have a look at this. Capacitor. Oh yes. So, open the 7th door. It's a 100 microfarad capacitor. It says pay attention to the polarity of it. So you can see here we've got the little stripe with a negative sign. So this is the negative terminal, and the other side with no stripe is a positive. So you need to make sure you get the polarity right on this. So it's basically a capacitor. It's got 2 metal foils which are insulated from each other. That can be electrically charged. It's normally a little bit of paper or some sort of poly material that separates the two. It's some insulator anyway. So it can store electric energy. So in this experiment, the electric capacitor the electrolytic capacitor charges itself up to the voltage of the LED, which is about 2 volts. It stores so much energy you'll hear a loud cracking sound when the switch is closed. For a very brief instant, the current flows through the speaker that is much larger than the current through the series resistor. So it says, caution, it must never be connected in reverse. This will destroy the insulating layer, will cause the liquid in the interior to get very hot, and as a result of substantial build-up of pressure. In extreme cases, the electrolytic can burst and release a corrosive liquid. This is particularly large when an electric capacitor is connected directly to a battery in reverse polarity. So say you must make sure that this is the right way around, and when they go pop big style, and you tend to find that this opens up and everything will shoot out the end. So we need to make sure this is in the right way here now, so we're connecting it. Positive there, negative there. There we are. So it says that you'll hear a loud cracking sound, so here we go. Yeah, that's much louder. You can actually hear it now. There we go. So that's pretty much as far as I'm up to. So it's the 9th, so we've got 2 more to open. So the 8th first. New territory. Don't know who's got fingernails this small, but mine aren't. Oh, what have we got in here? Looks like it's a ceramic capacitor by the looks of it. Where was I? Number 8. Inside there we have a ceramic capacitor. So it's a ceramic disc capacitor with a capacitor with a capacity of 100 nanofarads. Just come in a little bit closer so you can see this. There he is. He doesn't like to focus up close for some reason. So it's 100 nanofarads, and it's imprinted 104, which stands for 100,000 picofarads. So this capacitor has a capacity 1,000 times smaller than 100 UF, or 100 microfarad capacitor. So 1,000 nanofarads is 1 microfarad. So it's 100 nanofarads, this one. So it only stores 1/1000th of the energy of an electrolytic capacitor. Ceramic capacitors can be used in both directions, so they're not polarized. There's no plus or minus on this one. Zoom back out again a little bit. And it can withstand alternating voltages. So it works for AC as well as DC. They're also used at high frequencies and fulfill many tasks in a radio. So it says replace the electrolytic capacitor with a ceramic. So let's pop that electrolytic out. Let's pop the ceramic in. So the LED still stays lit, nothing changes there. But it says that the cracking sound is noticeably quieter. Which it is. So the battery connection remains the same for all of the following circuits. A negative connection is located on the bottom row of contacts, and it's also marked as earth or ground. In many old tube radios, the earth connection was connected to a large metal chassis that was grounded with an earth wire, i.e. grounded. Ground is not necessary for an FM radio, but the ground or earth marking is still present. So basically the ceramic doesn't store the same amount of energy that the electrolytic does. Okay, now the very last one, day 9. It says radio start. Well, let's have a look. Sounds interesting. Where's number 9? Come in, number 9. Anybody see number 9? There he is over there, look. Again, can't get my fingernails under there. Oh, hello. This looks interesting. Oh, behind the 9th door you'll find the radio integrated circuit. Oh, That is tiny. Wow. We need to make sure we get this connected up right. This could all go pear-shaped house. So it says, behind the knife tool you'll find the radio integrated circuit with 8 connection pins. So this is basically a radio chip. So we must be nearing the end of the radio once this thing goes in. Install this in the exact position shown in the diagram. This is important as the remaining space is needed in the subsequent experiments. Take care to ensure the IC is inserted the right way up and the positive and negative terminals are connected correctly. Incorrectly connecting the operating voltage can destroy the IC, as we know. Take care if the IC is difficult to insert. If necessary, use a pin to widen. Yeah, okay. To begin with, you'll probably only hear a quiet noise. Briefly press the wire switch. Station. Well, let's get it in circuit first. So it looks like we're swapping the circuit all around again. But pretty much this is the IC. Let's see if I can get you in a little bit closer here. Hopefully it's not static sensitive. Let's see if it'll let you get right in close there. There we are. Is this mounted? No, it won't let me do it. It's mounted on a little tiny board. So we've got a circuit board. And the IC is mounted on that. Just the back is just the pin outs. So this is the important bit to get the right way up. You can see it's got markings on it. SLR plus, VPA minus. So let's get this in the circuit. Pull some bits out here because everything's changing now. It's changing, switch is changing. The only thing that's remaining constant is the battery terminals by the looks of it. So we need to make sure this is in dead the right way. So it's got to be in pin 10 there, which is second one in. That way around. It does say it could be a bit stiff to get in. There it goes. Right, so now we've got a wire from this. So we've got to make a link. We've still got a link down the bottom here on the negative pin to negative there to the negative rail, so that's there. Incidentally, if you are working on breadboards, you can get from electrical suppliers a load of these jumpers pre-made, which makes things a lot easier. I'm not going to do it because it spoils it for this really, but I'm going to use this exactly as it is. I'm not going to change anything. But if you want to make this more permanent, you could do. So let's work from this point then. We've got the ceramic capacitor. That's going from the negative in line with pin P on the IC. We've got an antenna now. Antenna. I'm assuming that we're going to use the rest of this wire as the antenna, so let's cut a piece of that off. Let's strip a bit back. So that's in line with pin A there. Just sitting up and around that way. Got our switch down the bottom here. So that is going to there, down the bottom here. Yeah, these are a bit stiff when they're new. So we count these then. So we got 1, 2, 3. That's in that line. Yeah, that's right. So then I'll add a bit of switch. Let's go in. If I go in, there we are, in there. And this in out 2, and in there. There we go. So that's our switch in. We've got another jumper wire going in from our switch, so we want the end of this wire. Let's pinch another bit of this. That's going up in line with the switch up here. It's coming up 2 terminals up from the S. As I say, it does say to make sure you get these in the right position, because otherwise you'll be messed up for the experiments in a minute. So we're getting there. So now our capacitor. Okay, making sure we're the right way around. So we've got the positive going to the terminal L next to the switch, or to the link to the switch, and then the other side is going over level of that one at 3 down. No, the next one in there. Hopefully you can see this. It's coming together. Okay, that's the story so far. Positive and negative are still the same. This little bridging wire is a pain. It's not particularly working very well. Little holding wire, that is. Probably me cutting it too short, I expect. So that one is going from the positive rail, 3rd pin in, 4th pin in even, to 2nd pin down, there we go. Got another little link to do. There's another link to go in. Oh, I don't know whether these are still in the shops now, but as I say, it's only the 9th, so if anyone fancies going out and getting one, they should be there still. So according to that, it's the 3rd one in along, so we need a bridge there. Again, that's just linking us up to the negative wire, and then we're basically popping that LED across. Let's get the speaker in as well, better do that in a minute. In there, and in there. And we'll pop the LED, and that looks like that's going to be the last bit of the circuit. It should, in theory, so not a dicky bird. So we should hear something that says. Just make sure I've got that right. switch should go to the S. Maybe it's the aerial. We're looking at that. The switch should start at scanning, but doesn't appear to be. But if you press the wire switch, no canny or nothing. Oh dear, do you have to fault find this already? Oh, hang on a minute. We have got a jumper missing. Right at the top. You've got to pay attention to these things, look. There's me trying to fault find it already. We have no positive supply to the IC, which is why it ain't working. So that is going to be on the positive rail. There. Yay! Ah! Yay! We have ignition. Right, let's try it again. So touch that momentarily. Oh, touch it again. Ho ho ho! Magic stuff, it works. That's purely because I didn't put any power to the IC there. So it's just left that link out. Touch it again, get it to scan. Nothing there.
Those things will become more and more important as algorithms start being used in the public and private sector.
Well, there we are.
Dave Murray Rust, a lecturer in design informatics at the University
It works.
Edinburgh, is also interested in our online identity,
So,
especially how people interact with data and the control they have over how their data is used.
One of the big challenges is context. So you see examples where real-world situations meet online situations.
let's just pop a battery out to break the switch. There we go. A lovely little Haynes radio. So, join me every day and we'll build this up. Let's say we're not even halfway there at the moment, so there's plenty more bits and pieces to come on this. As I say, if you want to follow along and build your own kit, they should be available still. Yeah, great stuff. Thanks to Trevor and Joe again, and join me tomorrow for Day 10's episode. Bye for now.